Good afternoon, student. Today, plus one chemistry, thermodynamics continuation, pressure volume work, that is PV work. Pressure volume. Pressure volume work, that is PV work. Generally, say thermodynamically work, the gas become two kinds of possibility. First, number one, compression. Second one, expansion. Compression on the work, the gas. Second one, expansion on the work. There are two kinds of possibility. First, number one, compression. Second one, expansion. Okay, let us consider one by one. In thermodynamically, the pressure volume work. The pressure volume work, a gas on the system, by the system. A gas on the system or by the system, depending upon the pressure of external and pressure of internal. Pressure of external and pressure of internal. The difference between pressure of external pressure and pressure of internal pressure. Difference. The difference between pressure of external and pressure of internal. Okay. Let us consider cylinder. In the cylinder filled with N mole of ideal gas. N mole of ideal gas, that is gas. Internal pressure. Force, piston of force, that is A. Cross-sectional area, A. Cross-sectional area. This is dx. This is ideal gas. They take the N mole of ideal gas filled with one of the cylinder. Suppose external pressure of external. The outside the pressure, that is pressure of external. To calculate the work. Pressure of external is getting into pressure of internal. Okay. Next we calculate the work. W equal to minus F into dx. Work. Change the displacement. Work into dx. We know that pressure equal to force by area. Pressure equal to force by area, that is P equal to F by A. I need force, so F equal to P of A. P into A. This is equation 1. Next, this is equation 2. To compare equation 1 and 2, minus F, that is F. So work W, that is equal to minus P of external pressure into A, cross-sectional area A, into dx, that is del x. Then x. We know that A cross-sectional area and del x is nothing but volume of final minus volume of initial. A into del x, that is equal to volume of final minus volume of initial. Any substitute. W, that is equal to minus pressure external volume of final minus volume of initial. So W, that is equal to pressure external volume of final minus volume of initial is nothing but dV. Change in volume. Here work is a positive. Here work is a positive. So work is a positive, a gas become compression. A gas become a compression. W equal to pressure external into dV. So work become a positive, a gas become a compression. So finally we are conclude work done on the system. It's very important. Based on one more question. Finally, work is a positive, a gas becomes a compression. Finally, we are conclude the work done on the system. In case pressure is not a constant, in case pressure is not a constant, work reverse process. Work reverse process, that is equal to minus volume of initial and volume of final. Volume of initial and volume of final. Integration of volume of final equal to pressure external into dV. Change in volume. Change in volume equal to work reverse, that is equal to minus of integration of volume of initial and volume of final, pressure external into dV. Change in volume equal. Suppose point number 1, in a compression, the compression of gas, pressure external is always greater than to pressure of the system. In a pressure external, the process become compression. So pressure external always is greater than to pressure of the system. That is compression. Suppose expansion, this is nothing but pressure of external. Pressure of external, that is equal to pressure of internal plus dP because of positive. This is compression. Suppose expansion. Expansion's ka pressure of external always less than. Pressure of external is always less than. So pressure of external is always less than to pressure of system. Pressure of system. We can be represented pressure external, that is equal to pressure internal minus dP. Finally, pressure external plus or minus pressure internal dP. So pressure is not a constant. Let us consider pressure and volume. That is volume of final, that is volume of initial. Volume of final and volume of initial group. Best proportional. When a volume becomes decreases, with increases the pressure. Finally, work reverse process. That is equal to minus volume of initial and volume of final. Volume of initial and volume of final group. Volume of initial and volume of final, P internal into dV. P internal into dV. Already you know ideal gas. Because of cylinder filled with ideal gas. So cylinder filled with ideal gas kuda, the ideal gas formula PV equal to nRT. PV equal to nRT. So PV equal to nRT, pressure of initial, that is equal to nRT by V. So pressure of initial, that is equal to nRT by V. This is equation 1. This is equation 2. Equation 2 substitute on equation 1, pressure. So, work reverse, W that is equal to minus integration of volume of initial and volume of final. Volume of initial and volume of final, P initial nRT by V. So, nRT by V into dV. Into dV. Work that is equal to minus nRT. Integration of volume of initial and volume of final. Volume of initial and volume of final dV by V. dV by V. So, W that is equal to minus nRT learn. dV by V is nothing but volume of final by volume of initial. Work that is equal to minus nRT learn volume of final by volume of initial. Learn converted to log into 2.303. So, W that is equal to minus 2.303 nRT log of volume of final by volume of initial. Final. So, work become a negative. Work become a negative expansion. Work become a negative expansion. Finally, we are conclude the gas become whether it is an expansion or compression. So, volume of final is getting into volume of initial. Volume of final is getting into volume of initial. That is expansion. Volume of final is getting into volume of initial. Expansion, the value become negative. The value become negative. Finally, work done by the system. Work done by the system. Second, number 2. Volume of final is less than to volume of initial. Volume of final is less than to volume of initial. The gas become compression. Compression, positive value. Positive value. Work done on the system. Work done on the system. This is PV work, pressure and volume. Finally, volume of final is greater into volume of initial. Volume of initial is less than to volume of final score. Value becomes a negative expansion, work done by the system. When a volume value becomes work becomes a positive. So work is a positive compression, work done on the system. This is called pressure volume work, that is PV work. Next, we are discuss about some thermodynamic process, especially first number 1, heat is one of the energy. It can be represented as a Q. It can be represented as a Q. Generally, is a heat, that is temperature. There are 2 types of energy. Temperature, exothermic and endothermic process. Exothermic and endothermic process. Exothermic process, heat become liberated, evolved. Endothermic process, heat become absorbed. All combustion reaction takes place exothermic process. Heat is liberated. Heat is liberated. Exo. Endothermic process, surrounding heat, system is absorbed. Let us consider this is system. System. This is surrounding. This is a surrounding. So surrounding heat, system is absorbed. Surrounding heat, system is absorbed. A reaction become endothermic process. Suppose system heat become liberated. A reaction become exothermic process. Exothermic process. First point number 1. A boundary becomes separated. System surrounding, this is a boundary. A boundary becomes separated at different temperature. At different temperature. First number 1. System surroundings. System and surrounding. A different temperature, boundary becomes separated from the system. From the system. This is known as heat energy. Heat energy. Unit of heat energy. Unit of heat. The SI unit of heat energy, Joule. Can be represented as J. Joule. Commonly, it can be represented as calories. Commonly, it can be represented as that is a calorie. Okay. Next one, sign convention of heat energy. Sign convention of heat energy. That is plus Q and minus Q. Plus Q and minus Q. First one, plus Q. System. This is surrounding. When a surrounding heat system becomes absorbed, heat energy is grown. When a heat energy is absorbed from the surrounding. From the surrounding. This is known as plus Q. Plus Q. When a heat energy is absorbed from the surrounding. From the surrounding. This is known as plus Q heat energy. Next one, minus Q. This is system. System. This is surrounding. This is known as surrounding. System heat becomes liberated to the surrounding. System heat energy becomes liberated to the surrounding. This is known as minus Q. Generally, it can be endothermic. Heat is absorbed. Endothermic process. Minus Q, that is exothermic process. Exothermic process kuda. That is sign conversion of heat energy. Next one, the important one more, heat energy become a path function. It's a very famous one more question. Heat energy become a path function. Okay. Next, work. Work. Next one is work. So W, work, that is equal to minus F into X, force into displacement, X. W, that is force, into displacement. Some work can be done. Work. First point number 1, work is a path function. Work is a path function. That is boundaries of the system. The work become in separate boundaries of the system. Next, only change in state. Only can change the state. The difference between the boundary of the system, work is a path function. Only can change the state, not a system. Only can change the state. Okay. Next, unit. Unit of work. Generally, it can be represented. Generally, SI unit of work, Joule. SI unit of work, Joule. 1 kilojoule, that is equal to 1000 Joule. 1 kilojoule, that is equal to 1000 Joule. Okay. Next one, sign. Sign conversion. Sign conversion of work. Sign conversion of work. Suppose work becomes a negative. Work becomes a negative. The system becomes decreases. The system becomes a decreases. Negative work. So negative work minus W. Minus W. So minus W decreases the system. decrease the system. Work done by the system. Work done by the system. Suppose work is a positive. Work is a positive. System become increases. System become increases. So system become increases. Work done on the system. Work done on the system. Work done on the system. Suppose the work done by the system, a gas become expansion. A gas become expansion. Suppose what is a positive work done work done on the system. So work done on the system, compression. Work done on the system, compression. Okay. Heat energy, sign conversion. First, heat is absorbed. Heat is absorbed by the system. Plus Q. Second one, heat is evolved by the system. Minus Q. Minus Q. Plus Q, heat is absorbed. Heat is absorbed from the surrounding. Heat energy absorbed from the surrounding. Plus Q. Heat is evolved by the system minus Q. That is a sign conversion of heat energy. That is heat. Second one, work. Second one, work. Work become negative. Work done by the system. Work done by the system. Negative. Suppose work become a positive. Work done on the system. Work done on the system. So sign conversion of work, negative work. Work becomes a negative. Work done by the system. Work done by the system, that is expansion. Gas become expansion. Plus work. Work become a positive. So work become a positive. Work done on the system. Work done on the system, that is compression. Okay. Next go to thermodynamic zeroth law. Okay. Next one, thermodynamic zeroth law. What is the statement? What is the statement of one zeroth law? If two systems are separately. If two systems are separately. Okay. Let us consider, that is B. Next is C. If two systems are separately in thermal equilibrium, with a third one, this is third one, that is A. Third one, they have tend to be a thermal equilibrium with themselves. This is a two connected, two separated. The two separate are two system are separately is connected to the thermal equilibrium, but the third one is connected. This is one first system, that is a second system. It's a thermal equilibrium with a third one. They are trying to be a thermal equilibrium with themselves. This is a two separate thermal equilibrium. Third one become a connected. This is called zeroth law. Zeroth law. Okay. Once again, finally conclusion. First work. Unit of work. Sign conversion of work. Next heat. Unit of heat. Sign conversion of heat. Next pressure volume. PV work. PV work. So sign conversion, especially work. W minus. That is negative. Negative work done by the system. Next positive work done on the system. Work done on the system. Heat plus Q. Heat is absorbed. Minus Q guda. That is heat is evolved. Heat is evolved. Minus Q. Heat is evolved. Pressure volume guda. So pressure volume work. So pressure volume work becomes a positive. Work becomes a positive. That is compression. Suppose work becomes a negative guda, expansion. Okay, thank you.